In January 1995, the United States government loaded 14 gray wolves into steel shipping crates in the wilderness of Alberta, Canada, and drove them across the border into Yellowstone National Park in Wyoming. The wolves had been extinct in Yellowstone for exactly 70 years. The last wolf pack in the park was systematically hunted and killed by federal predator control agents in 1926, part of an official government policy to exterminate all large predators from American public lands. By the time those 14 wolves stepped out of their crates into the Lamar Valley, the ecosystem they entered had been unraveling for 7 decades. What those 14 animals did over the next 30 years triggered a chain of ecological changes so dramatic and far-reaching that it reshaped not just the animals and plants of Yellowstone, but the physical geography of its rivers. Scientists call it a trophic cascade. It is the most famous example of ecological chain reaction ever documented in a national park, and it started with fewer animals than a typical high school classroom. The absence of wolves had created a slow-motion catastrophe that nobody fully recognized until the damage was already severe and widespread. Without their primary predator, elk populations in the northern range of Yellowstone exploded beyond any historical precedent. Herds numbering in the thousands grazed freely and continuously through the river valleys, eating everything they could reach. Willows, aspens, and cottonwood trees that once formed dense corridors along the riverbanks were stripped bare to the ground. Young tree saplings never grew taller than a few inches before elk chewed them down to stubs. The loss of riverside vegetation triggered a cascade of destruction that reached far beyond the trees themselves. Without root systems to anchor the soil, riverbanks began to erode and collapse into the current. Streams that had been narrow and deep became wide, shallow, and braided. Water temperatures climbed as shade disappeared from the banks. Aquatic insects that depended on cool, shaded water declined. Fish populations suffered as spawning habitat degraded. Beaver populations crashed because willows, their primary food and construction material, had been eaten into oblivion. By the time wolves returned, only a single beaver colony survived in the entire northern range of the park. The 14 wolves released in 1995, and an additional 17 released in 1996, began changing the system faster than any scientific model had predicted. The wolves hunted elk, reducing the herd through direct predation. But the killing itself was not the primary mechanism of ecological change. What mattered far more than the number of elk killed was the behavior change in the elk that survived. The surviving elk began avoiding areas where wolves could easily ambush them, particularly the river valleys, narrow canyons, and steep terrain where escape routes were limited and visibility was poor. Biologists call this behavioral shift, the ecology of fear. Its physical effects were visible within just a few years of the wolf reintroduction. Willows and aspens began growing back in the river valleys that elk now avoided. Trees that had been suppressed at ankle height for decades shot up to 15 and 20 feet within 6 years. Cottonwood saplings that had been grazed to stubs every spring suddenly grew past the browse line and began producing shade canopy for the first time in a human generation. Beavers followed the willows. As soon as trees along the streams grew tall enough to provide food and building material, beavers recolonized waterways they had abandoned decades earlier. They built dams that created ponds, wetlands, backwater channels, and flooded meadows. The number of beaver colonies in the northern range of Yellowstone increased from 1 in 1995 to more than 120 by 2024. Each beaver dam stored water during snowmelt, slowed erosive flood flows, raised the local water table, and created habitat for fish, amphibians, waterfowl, songbirds, and aquatic insects. The rivers themselves began to change shape. Streams that had been eroding and widening for decades started to narrow and deepen as root systems stabilized the banks. Natural meanders returned where channels had been running straight through collapsed terrain. Side channels reconnected to the main river flow. Gravel beds reformed in the current. The physical geography of the river valleys was being restructured by a chain reaction that started with 14 wolves and a single missing emotion in the elk population: the fear of being hunted. Songbirds returned to the recovering forests along the rivers. Migratory warblers, flycatchers, and thrushes found nesting habitat in the new tree canopy that had not existed for decades. Ravens and magpies fed on wolf kills left in the snow. Grizzly bears scavenged carcasses abandoned by wolf packs, gaining a critical protein source during the spring months when bears emerge from hibernation hungry and vulnerable. Even trout populations showed improvement, as water temperatures cooled under restored shade and deeper pool habitat formed behind beaver dams. The scientific debate about the true strength and scope of this trophic cascade continues to this day. Some researchers argue that the wolf effect has been overstated by popular media. A 2025 peer-reviewed study published in Global Ecology and Conservation challenged earlier claims about the speed and magnitude of vegetation recovery, arguing that drought, fire suppression, and other management changes also contributed to the changes observed. The researchers who originally documented the cascade responded with their own analysis, defending the data. The debate remains active and unresolved in the scientific literature. But even the most cautious critics acknowledge that the reintroduction fundamentally altered the ecological dynamics of the park. The Yellowstone wolf population has stabilized at roughly 100 animals organized into approximately 10 territorial packs. Wolf-watching tourism generates an estimated $82 million annually for the gateway communities surrounding the park. Tour operators report that wolves are the single most requested wildlife species among visitors, surpassing grizzly bears, bison, and elk. The wolf reintroduction cost the federal government approximately $30 million over 3 decades. It returned an apex predator that had been missing from the ecosystem for 70 years. And it demonstrated something that ecological theory had predicted, but nobody had ever proven at this scale in a real landscape. A single species, reintroduced at the top of a degraded food chain, can trigger a cascade of changes that reaches from the largest predator in the ecosystem to the physical course of the rivers flowing through it. 14 wolves did what 70 years of park management and billions of dollars of federal spending could not accomplish.